You're listening to Review Recording 1ABC, watching it too. It accompanies instructional recordings 1A, 1B, and 1C for Section 1.5, Unit 1, Chapter 1, Mathematics 2200. We're going to be using the formula for the sum of an infinite geometric series and solving a problem involving an infinite geometric series. Example 1. The terms of an infinite geometric series are generated by the formula t sub n equals 1/3 to the n minus 1, where n belongs to the natural numbers. To what value, if any, does the series converge? Remember the formula s sub infinity equals t1, t sub 1 over 1 minus r, provided the common ratio is between -1 and 1 and r is not equal to 0. We'll note that our related sequence formula, which is given to us, was generated by the general formula t sub n equals t1 times r to the n minus 1. And we are given that t sub n is equal to 1/3 exponent n minus 1. That means our common ratio must be 1/3, because our t sub 1 must be 1. So r is equal to 1/3, and we note that 1/3 is between -1 and 1. That's true. So our series converges because it passes that test, so that rules out D. Therefore, for this problem, s sub infinity is equal to term 1, which is 1, over 1 minus 1/3. So it's 1 over 2/3, which gives us 1 times 3 over 2, which gives us 3 over 2. And we have C as our correct answer. Example 2, a ball is dropped from an initial height of 20 meters. On each bounce, it rebounds to 60% of the height from the previous bounce. Assuming the ball could continue bouncing an infinite number of times, find the total of the vertical distances the ball would travel. The drop distance is 20 meters. On bounce 1, the ball gets up to 60% of 20, which is 12 meters up. But don't forget, it's got to drop back down to the floor another 12 meters. So really for bounce 1, that's a total of 24 meters the ball travels up and then down. On bounce 2, the ball gets up to a height of 60% of 12. Decimal 6 times 12 is 7.2 meters. On bounce 3, it gets to 60% of 7.2, which is 4.32 meters, etc. So let's deal with the ups first. The sequence we have for the bounces is 12 plus 7.2 plus 4.32, etc. This is going on to infinity. It has a common ratio of decimal 6. Decimal 6 is between -1 and 1, and it's certainly not equal to 0. So that's a true statement, therefore converges to a sum. S sub infinity is equal to term 1 over 1 minus r. So term 1 is 12 over 1 minus the r value, that's 1 minus 0.6. That's 12 over decimal 4, which is actually 30. Remember the downs, not including the drop distance. That equals the distance traveled on the ups, so that's another 30. Therefore, our total vertical distance can be calculated. Pretty straightforward now. It's the ups, the downs, and the drop distance. That's 30 plus 30 plus 20, which equals 80 meters. In conclusion, key ideas. The formula S sub infinity equals t sub 1 over 1 minus r, where n is a natural number, provided it passes this test. The r value between -1 and 1, r can't be 0. If it meets these restrictions, then the series has a sum and it is said to converge.